Let's unpack this. Today we are taking a deep dive into something really specific, but at the same time, incredibly broad.
Right.
It's the Spring 2026 syllabus for CS326, Software Engineering, at Skidmore College.
And we're not just looking at it like an academic document.
No, not at all. We're treating this as a blueprint, a modern blueprint for professional success in, let's be honest, the high-stakes world of enterprise software.
Exactly. And our mission here is to really pull out the organizational and the philosophical principles that are just so vital for building those big enterprise-scale applications.
Mm-hmm.
Because it's clear right from the start, success is about way more than just writing clean code. It's about communication, process, all the human stuff.
That human stuff is so critical. Their instructor, Dave Reed, he's explicit about it. The course requires, significant design, programming, testing, all the hard skills.
Sure, the fundamentals.
But it's really about the role of software engineering inside the organization.
Right.
And they have this one core soft skill they prioritize.
Let me guess. Communication.
Exactly. The ability to, and I'm quoting here, communicate effectively with non-technical business leaders. That's the whole game.
It really is. And you can tell how serious they are about teaching these foundational principles because of the required reading. It's not just the latest tech manuals.
Right.
We're talking seminal works. We're talking lessons learned from engineers who've been in the trenches for decades.
Like what?
The Mythical Man Month
A classic.
by Frederick Brooks and The Pragmatic Programmer by Thomas and Hunt. These are the foundations.
I really appreciate that. I mean, why is the Mythical Man Month a book famous for its insights on, team size and scheduling problems? Why is that so crucial for a 2026 course?
It is the ultimate reality check. I mean, Brooks's main idea that adding more people to a late software project just makes it later,
Right.
that's a timeless lesson in just how complex project management and communication can be. It teaches students from day one that this whole thing is constrained by human factors, not just CPU speed.
So they're expected to think like managers and historians, not just coders.
It's exactly.
Okay, so let's shift to the high-level objectives. What does enterprise-level software development actually mean in this class? It seems like a very integrated view.
It is. They break it down into three core areas. First, you have to understand the technical and the managerial concepts. It's not enough to know the framework, you have to get the business case.
Okay, that makes sense.
Second, and this is where the tools come in, they have to identify and use techniques for, the whole life cycle.
Yeah.
Requirements, design, implementation, testing, all the way to operational challenges.
Which flows right into the third one, which is coordinating the team and delivering working software using an agile methodology.
It's the professional discipline laid bare.
And they reinforce this by connecting it to these broader college-wide literacies. So engineering isn't in a silo.
No, not at all. You've got information literacy, which is basically using your sources with integrity. That's essential for technical docs.
And they also hit on oral communication literacy. Students have to give organized presentations with language that's appropriate for the audience.
And there are those non-technical business leaders again.
Exactly. You're forced to practice talking to them.
And then there's technology literacy, using your development environment effectively, and maybe most critically for enterprise work, visual literacy.
Which isn't about graphic design.
Not at all. It's being able to read and interpret diagrams, UML, architecture blueprints, flowcharts. You can't build a system if you can't read the map.
What really stands out to me, though, is the advice on prioritizing user experience, UX, over the programmer's effort. There's this thing called the Robinian-Storm rule.
Ah, yeah.
It just states directly, you cannot technically explain yourself out of UX issues. Please stop trying.
That is the ultimate test of user empathy, isn't it? The core idea is that your effort as a programmer is completely irrelevant if the product is hard to use.
And they give that specific example. A user says, this is hard to use.
Right. And the programmer's reply should never be an explanation of how hard it was to build. Well, it took me 3 months because library A and library B are so complex to integrate.
Which is the first instinct, to defend all your hard work. But that's all about your feelings, not the user's problem.
Precisely. The focus has to pivot immediately to listening and actually solving their issue. The instructor was blunt about it.
Mm-hmm.
If the software doesn't align with the user's paradigm, it is destined for the bit bucket.
Wow. And that's not just bad code. That's hundreds of hours of salary and time just wasted.
Totally wasted.
That kind of focus requires a really mature team, which brings us to how they structure team dynamics.
Yes. And the structure itself is a philosophy of growth. The instructor usually spends time at the start of the semester talking about how to learn before they even get to what to learn.
So they're teaching metacognition.
Basically, yeah. They're aiming for active acquisition of knowledge, combining new stuff with old stuff, and being able to apply it in new situations.
And they actually dedicate class time to the science behind it. Things like short-term memory, attention, encoding techniques, even intrinsic motivation. Why spend lecture time on cognitive psychology?
Because the ability to learn complex, changing material is the most valuable asset an engineer has. They're teaching continuous improvement, but for the student's own brain first. If you get how your memory works, you can study better, and that makes you a more effective professional.
So that sets the stage for the team environment, which is like a little microcosm of a professional dev shop. They have these rotating leadership roles for team meetings.
This is where it gets really interesting. They institutionalize meeting management. You have the chief understanding leader.
Okay.
Their job is to verify that everyone on the team is on the same page. No more silent nodding.
Yeah.
There's the chief note taker for non-programming meetings.
And then the chief equity leader who makes sure everyone gets a chance to talk. They can even call on people. But
Right.
doesn't that risk making it feel a bit bureaucratic? Could it stifle the organic flow?
It's a calculated risk, I think. But in a learning environment, it's necessary. In the real world, you always have one or two dominant voices who accidentally shut down other people.
That's true.
The equity leader is a direct counter to that. It forces students to practice active listening. It's a real management skill.
Speaking of management, they have a clever system for handling stress.
Yeah.
These 3-day extension coupons.
I love this system. It builds in both flexibility and accountability. Students get 2 coupons. They can use them to extend a lab by 3 days or even postpone being a discussion leader. It's a way to handle life, sickness, burnout, whatever.
But get this, unused coupons add 1 point to your final grade. So doesn't that incentivize people to just suffer in silence instead of using a tool that's there to help them?
I see what you're saying, but I think that's the key distinction. The incentive isn't a reward for suffering. It's a reward for meticulous planning. It encourages you to build buffers into your schedule so you don't need the emergency extension. It's training you to estimate accurately, which is maybe the most valuable skill in project management.
And to keep that personal connection, every student has to meet with the instructor at least once every 3 weeks, just to check in, ask questions, and reflect.
That's high-touch mentorship. It underscores that this isn't just about code, it's about the person writing the code.
And this is where the syllabus really feels like it's from 2026. The integration of large language models.
Yep. The course got an AI microgrant for a license to ChatGPT's API, so they're leaning into it.
But it's very controlled. It's structured as a research opportunity. All LLM interactions have to go through this custom tool called the BitBuddy application.
So this isn't just, asking ChatGPT for code snippets. It's an audited pipeline. The BitBuddy tool keeps a history of every prompt, every response, and the user's feedback.
Why?
So they can do research on the LLM's strengths and weaknesses across the entire development lifecycle.
So they're not just using the tool, they're studying the tool itself.
Yeah.
Which is reinforced by the LLM Friday Roundtable.
Right, where they debate articles and videos about the impact of LLMs, first on development and then on society as a whole. It's very thoughtful.
This kind of controlled experiment means you need a really robust ethics framework. And the big rule here is about citation.
A very big rule. Any LLM-generated content requirements, documents, source code, it has to have a clear citation. Specifically, the BitBuddy payload IDs.
That payload ID requirement feels revolutionary for accountability. I mean, beyond just catching cheaters, what's the professional reason for forcing engineers to cite their AI inputs?
Oh, it's absolutely critical for the working world. This isn't just about plagiarism. It's about an auditable chain of custody for code.
Okay.
In the enterprise, you need that for IP protection, for liability, for future regulations. If a bug gets traced back to AI-generated code, you have to know exactly which prompts led to which output. The payload ID is that forensic trail.
That makes perfect sense. But then they draw this incredibly sharp line on human collaboration once coding starts. The syllabus says, quote, "When you start writing code, it is time to stop sharing ideas."
Yeah, that's a direct response to how tricky teamwork can get. Helping a classmate with a syntax error, that's fine. But looking at their program for reference or using their code, that's improper collaboration.
And the goal is that the final program has a single, easily and uniquely identifiable author.
And critically, they say if you can't explain the thought process behind your own code, that's evidence you crossed the line.
Which leads to this fascinating paradox with the AI rules. They say using any online source, including AI code, without attribution is a violation. The only way to use an LLM is through that audited BitBuddy tool.
The paradox is intentional. It models the pressure of a professional environment. You have to use cutting-edge tech, but you also have to follow strict corporate security and IP policies.
So they're forced to create their own team standards for LLM use before they even start coding.
Exactly. That's a huge part of the exercise.
Okay, let's talk about accountability outside of exams. It seems to lean really heavily on student-led learning.
It does. Accountability is baked into the documentation process. For example, students are chosen at random to lead discussions on the readings.
At random, so you have to come prepared for every single class. You can't just coast.
No coasting. And the leader's job isn't just to summarize. They have to outline the big points, facilitate a real conversation with different viewpoints, and then document everything, the reading's main points, and the discussion on the class wiki before the next meeting.
That is an immediate, high-stakes feedback loop.
And that wiki documentation means every reading becomes institutional knowledge for the whole development shop. It's practical. Then, for individual reflection, they have weekly journaling.
Right, in a blog, podcast, or vlog format.
And the requirements for the journal are so revealing. Key points, extra concepts, study questions for peers. Critically, they have to record their aha and ha moments.
That's the practice of metacognition again, thinking about your thinking.
Exactly. By writing down the aha moments, you solidify what you've learned. By writing down the ha moments, you identify what you're still confused about. It forces them to get into the habit of continuous improvement, not just for their code, but for their own learning process.
And when you look at the grading, it confirms all of this. 45 points for the actual development work, but a full 20 points for participation, which includes those notes and journal entries.
The structure mirrors professional expectations perfectly, and that participation grade is tied directly to attendance. You get 2 absences, but otherwise, late work gets a 0 unless you've made a prior arrangement.
It just establishes that showing up, being engaged, and hitting deadlines, they're non-negotiable.
They are.
So when we step back, this deep dive shows that modern software engineering education is really an exercise in applied professional discipline. It's this blend of deep technical knowledge, organizational challenges, ethical navigation, and all those crucial interpersonal skills.
And if we go back to that mission, understanding what it takes to succeed in enterprise software, I see 2 core tensions that this syllabus forces you to master.
What are they?
First, there's the tension between agile, interdependent teamwork, and that really strict individual accountability with the payload IDs and no code sharing. You have to be a great collaborator and a single auditable owner of your work.
And the second one?
The tension between that intense, technical, focus-building complex systems with difficult libraries and the radical empathy you need for the user, that whole UX versus effort argument.
You have to put the user's experience before your own technical struggle.
It really makes you realize the modern engineer isn't a solitary code wizard anymore. They're more like an organizational and ethical guide who also happens to write incredibly complex software.
Absolutely. And since the course starts with how to learn, exploring short-term memory and attention, the provocative thought I'd leave you with is this. If learning is an active process of acquiring and applying knowledge, how can you immediately adopt the growth mindset and reflection techniques from this syllabus to approach a problem you're facing right now, even if it feels overwhelming? Don't just work on the problem. Start by deliberately recording your own weekly aha and huh moments to really understand your process.